GATE 2014 set 3 electrical question number 32. A series RLC circuit is observed at two different frequencies. If omega 1 equal to 1000 radians per second, it is noted that voltage V1 equal to 100 angle 0 results in current I1 equal to 0.03 angle 31 ampere. At omega 2 equal to 2000 radians per second, voltage is observed V2 as equal to 100 angle 0 volts, which results in current 2 angle 0 ampere. Then the value for these two given, then the closest value for RLC are asked. You can refer to NPTEL reference lecture number 47 numerical examples 1 of the NPTEL course network analysis by Professor Taposh Kumar Bhattacharya, Department of Electrical Engineering, IIT Kharagpur. So now useful data that we will be needing in order to solve this question is that for an RLC series circuit, that is AC, if you provide voltage V, which is a phasor, and the frequency is omega, then you can find the impedance Z, which is V by I, and the magnitude of Z is given by R square plus inductive reactance minus capacitive reactance whole square, then whole root over. This is the value of impedance for a series RLC circuit. Now how is it coming is that this inductor offers XL inductive impedance, capacitor offers XC in impedance, capacitive reactance, and the direction of this is in plus J direction, and the value of XL is J omega L, and the capacitor offers capacitive reactance in the minus J direction, and R is like this along the x-axis. So now along the real axis. So if R is like this, and the net reactance offered by combined effect of inductor and capacitor, if it is in the plus direction, when XL is greater than XC, then phi 1 will be like this, net effect in the anticlockwise direction. If not so, then the XC is greater than XL, then the net effect will be in downwards direction, so phi 2 will be in this direction, minus. So now we can write in a generalized form phi for given RLC as tan inverse omega L minus 1 by omega C divided by R, because omega L in the plus direction. So if it is more, then phi will be plus, and similarly the other way around. So now for different omegas, the value of V and I are given. For omega 1, omega 2, V and I are given. So now we can determine RLC values for this given network. So coming to the solution, now see, in the first case, voltage V1 equal to 100 angle 0, I1 equal to 0.03 angle 31, omega 1 equal to 1000 radians per second. Again, V2 equal to 100 angle 0, I2 equal to 2 angle 0, omega 2 equal to 2000 radians per second. Now from the observation, we see
that if this is the voltage V1, then the current I1 is leading the voltage V1.
It happens only if the circuit is capacitive dominant. What do I mean by this? That the capacitive reactance is more than the inductive reactance. This circuit, by seeing this, we see V2 is like this, and I2 is also in line with this. So this is a resistive circuit, purely resistive circuit, and net reactance X is 0. Now with this basic analysis, we can immediately say that the value of R equal to V2 by I2, which is equal to 50 ohms. Now R value is determined. What does this mean? That at this frequency XL equal to XC
At
2000 radians per second. So 1 by omega c, which is the capacitive impedance, must be equal to inductive impedance omega L for this omega. So omega value is 2000. So omega square equal to 1 by LC, or the value of omega V1 by I1 equal to the Z1, which is equal to 100 0.03 angle 31.
This is for omega 2. So omega 2 square equal to 1 by LC. So LC equal to 1 by omega 2 square. Now we see phi equal to minus 31. So phi can be written as tan inverse. Now if this is the impedance triangle R, this is omega L, this is 1 by omega C. Omega L minus omega C by R, tan inverse. If omega L is more than omega C, phi is positive. If omega L is less than omega 1 by omega C, it is negative. In this case, we see capacitive dominance, so it will be negative. And minus 31 is coming, so tan inverse omega L minus 1 by omega C by R, it is negative. So the minus 31 degree tan inverse omega, this is omega 1 obviously. So this is omega 1 square into LC. LC is 1 by omega 2 square. So omega 2 square minus 1 divided by omega 1 C into R. Now tan of minus 31 is minus tan 31. So minus tan 31, I can take this minus sign inside. So this is like this. So like tan 31 now into omega 1, which is 1000, into C into R value is known. So omega 1 value is known and tan 31 is known. C is to be determined. So this equal to 1 minus omega 1 by omega 2 whole square. So now this, solving this, C is coming out to be 25 microfarads, and putting the value of C here in this equation, we get L equal to 10 millihenry. So now C is 25 microfarads, L is 10 millihenry, R is 50 ohms. So the answer is option B. R is 50, L is 10 millihenry, and C is 25 microfarads. So option B is correct.